Okay.
This meeting is being recorded.
Yeah.
I noticed in the LinkedIn somehow it pointed to my Fayyad.com site, which I think the bio is not updated there. The best place is the northeastern .edu site for my bio.
The bio that Hassen had is exactly the
good one.
by Rana.
Yes, we got that.
Okay. All right.
So it's good. Hassen, you have the right bio. That Semi sent you at the morning.
Yes, I do. Yes.
So Dr. Usama, I'm Salma Jamousi, the host to send you the first mail. And I'm really very pleased and honored to have you with us today in the Tunisian Artificial Intelligence Society that I introduced before. Dr. Hassen will moderate this session, and Sami Ayari is the administrator of all this masterclass. He is the co-founder also of the Tunisian Artificial Intelligence Society.
Hi, Dr. Fayyad. We are really honored to see you in this masterclass.
Thank you. Thank you very much.
Many thanks for you.
Okay. So hello, everyone. And yeah, we are all have Dr. Fayyad leading this this session. I know it will take me maybe the whole session to introduce Dr. Fayyad, but I will try to be as brief as possible. And then please, there are, you know, if you want to learn more about his rich and exciting career, we'll share the links for that. So Dr. Usama joined the Northeastern University, the Holy College of Computer Science, as a professor of the practice, and also the Office of the Provost as the inaugural executive director of the Institute for Experimental AI. He's the chairman of Open Insights, a company he founded in 2008, focusing on technology and consulting. Previously, he served as the co-founder and CTO of OODA Health, Inc., from 2017 to 2019. Dr. Usama has an extensive background, including roles at Barclays Bank, Yahoo, Microsoft, and NASA. He holds a PhD in engineering in AI and machine learning from the University of Michigan, Ann Arbor, and is a fellow of both AAAI and the ICM. He has published over 100 technical articles, holds over 20 patents, and is an active angel investor advisor in many early stage startups across the US, Europe, and the Middle East. Without further ado, please, Usama, it's I'll pass the mic to you.
Thank you very much, Hassan, and Salma, and for the invitation, and Sami for the welcome. Thank you, everybody, and hope all is going well in Tunisia in these times. I will share a presentation, and hopefully you're seeing it in slideshow mode now.
We do.
Okay, so the goal here is to kind of very quickly, go through, I'll call it a super brief history of the context for AI and what's driving us towards this whole attention to generative AI. I will focus a lot more on generative AI because that's what everybody is concerned with these days. And I'll go back and talk about experiential AI and what we mean by it, and what's the role of it, and how to think about it. I think there's a lot of opportunities here that are worth delving into. As Hassan mentioned, I'm my background includes all sorts of startups, including in the healthcare space, Uda Health. I've held roles of chief data officer at Yahoo when they acquired my second startup, at Barclays as the global chief data officer, and through Open Insights worked with a lot of companies. Oasis 500, in fact, was an effort we did in Jordan, addressing the whole Middle East and North Africa. And in fact, we held a couple of training camps in Tunisia at one point, as well as part of that history. The main themes I will cover today is kind of the whole setting, the digital transformation, and why AI is getting so much attention today. The focus on generative AI in particular. What is it? How does it work? Where the problems are? A lot of the stuff that many of the companies and organizations and even academia don't talk about. We'll have I think maybe at most one case study, maybe two, to kind of understand the setting, and then talk about kind of responsible AI implications and where to go from here. And I'd like to leave some time for questions. Would love to have a lot of interactivity and questions and so forth. So let's start with digital transformation. All of you know the world has been going digital, accelerated through COVID, of course, the pandemic, but the digitization has been around for a long time. So take something like accounting, right? And financial services has been probably the oldest field to go through a lot of digitization. If you look at the accountant of 50, 60 years ago, you had to be good with managing ledgers. You had to have a good handwriting. You had to have good addition skills in your head. You had to have a lot of patience, because if you made an error, you had to go through all the paper documents and trails and fix all the numbers and all of that. None of those skills today apply to an accountant. Why? Because all of this got effectively encoded into software packages, into algorithms. Yesterday, I was actually at Intuit, the home of QuickBooks, and they were talking about how they're using AI even to do things like predict cash flow and send warnings and so forth to users of the systems. Yet, the question you ask is, has this replaced accountants? Do we have fewer accountants because of this transformation? And the answer is no. We actually have more accountants today than we've had in the history of human civilization. Why? Because the function actually, by digitizing it and by making it cheaper, faster, better, more accurate, it became more relevant to a lot more groups, to smaller businesses, to smaller departments, to many people who wouldn't consider accounting. And therefore, we needed the accountants to help us interpret, understand, act on the right level in terms of the implication of the numbers. Now, digital transformation, if it's not taken, can have dramatic consequences. An example I use often is Kodak went bankrupt at 124 years old. Think about everything it survived. It was a top global brand, right? They were it when it came to photography. They invented the digital camera, yet they failed to accept it as the future and decided to stick to film and print and paper as their core business. And despite the fact that they survived, the first Spanish flu pandemic, the depression, the world wars, all of that, they just couldn't survive that when others took on the business, the digital camera, and that completely redefined their field. JCPenney is a big retailer in the US, went through a similar kind of sequence where their competitors were taking on digital, they were not, and they had to declare bankruptcy at 118 years old. Other examples of excelling with data and transformation are Vitality, which is an insurance program that actually came out of South Africa, went to Europe. But the whole idea was, hey, can we include wearables and data about where you spend your money? And are you spending it on health club memberships and things like that, and use that to reduce the cost for the consumer and to gain the right kind of customers. Capital One in the US is infamous for leveraging AI and predictive AI, especially to turbocharge their credit card business. And DBS is an example, a bank you may not have heard of. In 2012, they were in trouble in Singapore. They were going out of business. They took on a digital transformation that emphasized analytics and data, and their comeback was huge. 5 years later, they became Singapore's largest bank, and the quotes and the numbers that they produced by embracing this were great. So in this talk, in that context of digitization, which creates a lot more data, AI has become kind of the preferred means for dealing with all that data that comes from the digitized processes and events and so forth. And getting AI to work is kind of one of the biggest grand challenges facing us today. So, AI in a few words, I mean, I don't need to explain it to this group, to this society. It's an old concept, in my opinion, goes back to the 1940s. In 1956, the name got formalized through the workshop, the infamous one in Massachusetts. And despite much hype and fear, there were a few good successes, but the excessive hypes, over time led to 2 AI winters in the past. In the mid-1970s, people kind of were disillusioned and said, okay, you promised us this is going to change all our lives, and it didn't. And then people were denying they had anything to do with AI for a while. When I was graduating with my PhD from University of Michigan in early 90s, I was entering, we were entering another AI winter where there was another wave of disillusionment, and people were going out of their way to deny having anything to do with AI. We're seeing a similar kind of hype happening today, which is a bit scary. As you all know, the definition of AI is very simple. It's the use of computers to simulate human intelligence. But unfortunately, for the past 80 years, we have been unable to define what intelligence is. In fact, even simpler things like common sense reasoning, which hopefully everybody knows how to do somehow, we still can't get machines to do that. And I'll talk about this. This is an important bit that relates to even generative AI. And what about machine learning? Well, it's a subset of AI concerned with machines modifying learning behaviors based on experience inputs and training data. So this is all kind of context. And now we have, we've beaten the best humans in playing chess. People used to think that, hey, if you could come up with an algorithm that plays better than most humans, then you must have cracked intelligence. Well, we did that. It didn't give us any insight as to the human intelligence and how we do it. We couldn't get these programs to generalize. Today, AI plays better Jeopardy than most humans, plays better Game of Go and Game of Life and all of that. So these things historically haven't had much of an economic impact. They were interesting developments, definitely an achievement. But now with generative AI, we're seeing an era where a lot of what's happening applies directly to the knowledge economy, and I'll talk about that in a second. So, I'll skip this actually. Both winters were survived by machine learning, right? And machine learning survived and thrived, not really because we developed new and better machine learning algorithms than other fields of AI. The reality is we just had a lot more data. And that was the big game changer that kind of kept machine learning going and surviving throughout both winters, and will continue to be the case even if we hit a third winter. So the 3 waves of AI are the classical that you know all about: expert systems, rule-based systems, scheduling, reasoning about uncertainty, machine learning. The second wave is mostly predictive AI and the emergence of deep learning, its first generations. And then we are now in the third wave, which is generative AI, which we will talk about more in this presentation, hopefully. And that's where we'll spend our time. So AI subset is machine learning. Subset of that is generative models, right? And if you ask me on the applied side, how does the picture look, right? Well, reality on the applied machine learning side, which is significant, probably the most, all working AI applications today, for better or for worse, are essentially machine learning. They rely on data science or machine learning or learning algorithms or statistical analysis or what have you, relying on data. So you have supervised learning, or what's called predictive AI, which is kind of the biggest by share, by far, in the market. Unsupervised learning, where you don't have labels for every data item, you don't have labels for any items in this case, and you try to group them by similarity, is a second. Gen AI is emerging and is having some commercial applications, but nowhere near as big as kind of predictive AI today. And then many other fields, and I don't show them all here, but if you think about reinforcement learning, which was in the beginning played a big role in Gen AI, no longer does now, they're still tiny in terms of their application and their significance economically. There are two themes that are kind of lost when people talk about AI and do AI and what it takes. The two themes are data is essential and human intervention is essential. What do I mean by that? It seems very obvious. If I say all working AI today depends on machine learning, well, you must have data there. But capturing the events, capturing the outcomes, capturing the context is very challenging. Similarly, all of the successful AI applications today, including things like Google search and so forth, and we may talk about that, they require a lot of human intervention. But capturing the guidance, capturing the corrections, capturing the context in which the corrections were made is also very challenging. So most organizations are really challenged to even capture the right data that they produce when they do their own business. The AI haves, the Googles, the OpenAIs, the Microsofts, the Amazons, the Ubers, Alibaba, etc. They understand this very well. And in fact, they hire a lot of people who will do the feedback, the intervention, and they will capture every little bit of intervention. I mean, I'll use Google as an example. The Google search engine, at its core, it decides which queries are relevant, which results are relevant to your 2.5 keyword query, let's say. That algorithm is decided by something called MLR. It stands for Machine Learned Relevance. That's an algorithm that uses about 500 to 700 features for every page on the web and uses machine learning to kind of decide the ordering based on your query. That algorithm is retrained 3 to 4 times a day, every day, based on, some of it from click-throughs, but most of it coming from teams, dedicated teams that do what's called search editorial. They look at a query result and say, oh, move this up, move this down. This is a meme, it means something completely different. Things that a machine cannot capture on its own. It needs these people, and they are combinations of crowdsourced, remote workers, contractors, and employees. And these are very big teams. The same, by the way, happens at OpenAI. The same happens at anybody who needs to train a large language model. These things are important and understood by the business. So this is Jamie Dimon, the CEO of the biggest bank in the US, JP Morgan. In his recent letter to shareholders, he mentioned data 27 times and talked about 300 different use cases for AI. So what is experiential AI? Experiential AI simply is our code word for AI with a human in the loop. We actually do believe that the human intervention is a must, and the working AI is really about kind of human-assisted machine intelligence as well as machine-assisted human intelligence. So that's how the two should work together, and that's how you get the best formula of everything working together. And we'll talk about this, and hopefully by the time I finish presenting, you'll get kind of those themes clear in your view, and feel free to, of course, ask me questions about this. The result, of course, of combining the human and the machine together effectively, as you see in many of the working applications, is you get much, much better results. So is there a human in the loop in ChatGPT? The answer is yes. In fact, there's many articles. This is one of the earliest ones that got published out there, but you can find many now that talk about how sometimes even humans intervene and start answering questions when they detect that the ChatGPT is going off course, as it often does, by the way. There's a lot of feedback, relevance feedback after the training, and we'll talk about that as we talk about generative AI. So there's a lot of human intervention, and a lot of it comes from also curating just the right data sets to make it work. And that's very important. So what is generative AI? Well, it's the generation of text, images, etc., from textual or multimodal prompt. Multimodal just means you have text and you say, hey, give me an image that looks like this and does that, or give me a reading of this article in the voice of that sounds like this, right? So it's multimodal in the prompt. These models are I technically refer to as stochastic parrots, and something to keep in mind. Parrots in that they do not understand what they're saying, despite how smart they may seem to be, and stochastic in that there's a degree of randomness in the answers you could get from them. If you train the model on language, you get generative AI for text, like 𝒂𝒏𝒂𝒕, Bard, Llama, etc. From Meta. If you look at images and train it on images, you get things like DALL-E, Stable Diffusion, Midjourney, and so forth. You can train it on code, and we'll talk about that use case, hopefully, if we have time. And it can produce code like, Python or SQL. You can train it on voice, music, etc., videos, what have you. You can also teach it to learn sentiment. Is this positive? Is this negative? You can teach it to kind of look at audio and, hey, did this call result in a sale or no sale? Is this a picture of what type of flower? All of that is easy. Here's a chart for you. The reason I show it very quickly is the good news on this chart is it's not just GPT out there. There's many, 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 many other alternatives. I am a fan these days mostly of Llama, particularly Llama 2, because Meta has enabled not only open source use, but also for research, but also free use for commercial applications. And that's a great platform, and we'll talk about it in one of the case studies. So ChatGPT itself is just a chatbot sitting on top of that model. Started with 3.5, went to GPT-4 underneath it. I don't need to explain what GPT stands for. You all know probably, but I want to emphasize something. GPT-3, which is the last generation of GPT where OpenAI remained open. We don't know now exactly what they're doing. We don't even know the size of their models. GPT-3 was 175 billion parameters, and we'll talk about that in a second. It's trained on 1 terabyte of text data, not on the whole web, and many people claim. In fact, they started trying to feed in data from the web. And what happened is what you expected. Lots of articles were contradictory to each other, lots of false information, lots of bad information, lots of hate speech. So they had to backtrack and basically go back and say, hey, let's curate. And this is where they spent their first biggest sum of money. And remember, they raised $2 billion in their first 5-6 years, 2 billion with a B. And then lately they raised another 10 billion from Microsoft. So a lot of money spent on carefully selecting the right balanced data set. They went to Wikipedia because it was moderated. They also went to publish scientific articles because they were safer to use, less likely to contain lies and false information. So that was a very important step that required a lot of human intervention. The other one is actually post the training, which we'll talk about. You need a lot of human intervening with the model to fix it and to re-guide it into the right places. By the way, most of the capabilities are not new. They were around since 2020, but it's really essentially just autocomplete on steroids. And it's autocomplete that depends on your prompt. So depending on what prompt you give it, it'll start its train on autocompleting, and we'll talk about that. And literally, I want you to know this, that it really is producing either a word at a time, a token at a time, actually, even part of a word. That's how it builds up a paragraph or a paper or what have you. And similarly for images, it's like a pixel or a region of pixels at a time, etc. And it's literally one step after the next. One thing to point out here, because the model here I mentioned, GPT-3 is 175 billion. We think GPT-4 is about 1.5 trillion parameters. Now, we don't know. They won't tell us. But I would ask you a question. How much do you think it takes to train that large language model of 175 billion parameters on 1 terabyte of text data, which is what they use for training? This is only like the energy cost. Disregard the huge cost of the equipment and the cost of training afterwards by humans. Many of you may or may not know this. One training run of GPT-3 is about $3 million worth of electricity, of energy, just to get that model of 175 billion parameters to converge. It's a much larger number, of course, for GPT-4, which is over 1 trillion parameters. this doesn't even include the cost of curating the right data and balancing it and all that, which is much larger. Why did it get so much attention? Well, because it reached 100 million users in 2 months. Compare that with, Google Translate or Uber that took about, over 70 months to get there. So that's really what got everybody to kind of wake up and notice it in a big, big way. We are now at kind of the top of the hype curve. We're amazed at what it does. People are beginning to notice it's frequently incorrect. People are beginning to get annoyed with how confident it is, even when it's incorrect. But then we'll reach kind of the maturity when we start saying, it's okay. This is part of the game. It will make errors, but it still is useful even with all those errors. It's not free, by the way. I'll give you an example. Typically, you have to pay to get it kind of fine-tuned to certain domains. So in our case, from the Institute, we had access to about 65,000 documents of about 10,000 characters each. They charge you by the character when you do this. And it's a cost of about, and these are about disease transmission, pandemic type stuff. The cost is about 50K to kind of pre-train the model with this data before you can ask it to do the tasks. So it's not free. Now the prices get reduced, but then as the model gets bigger again, the prices go up again. So it applies though to a lot of areas. Finance, legal firms use it, manufacturers, film and media, the medical industry, architectural firms, gaming companies, and the list goes on and on and on. And in each domain, like in finance, for example, you can go into many, many applications in credit and risk, in personalization, in fraud detection. Responsible AI is a very big deal. We'll talk about it towards the end. Automation, lots of automation focus these days, and in trading. The economic impact, though, and this is the difference between having a better chess player or a better game of Go player, are significant. Why? Because we created a knowledge economy. And in this economy, there's a lot of robotic repetitive work where these machines can actually help accelerate. We think the acceleration will be between 15 and 80%, depending on the type of work. But this is significant. Why? Because the size of the knowledge economy globally, according to the UN, it's between 19.6 and 30%. In the high-income countries, it's much higher. In the US, it's about half the economy. So even if the speed up is 5% of these knowledge worker tasks, you cannot ignore it just because of the size of the economy involved. Always important to have the human in the loop, because you need to check the output. The output is often wrong, and if you don't quickly correct it, you're in trouble. You need to modify and edit it, and you need to approve it. And this is where people get in trouble when they don't do that. I often get the question, will AI replace my job? And these days I give the answer very quickly. The answer is no. AI will not replace your job, but a human using AI will replace your job if you're not using AI. And that is the other message. This is why it's so important to figure out how to use this technology, how to leverage it, because it creates a lot of inequities. And we'll talk about some examples of those if you don't use it. So how do these things work, right? Let's spend a few minutes kind of giving you the quick summary, just to demystify. It all started with a perceptron from the 1940s until Frank Rosenblatt came up with his learning algorithm for perceptrons in 1958 and published a paper. Well, what's a perceptron? It's just a device, a network that has inputs. I called it, simple one here is 3 inputs. There's weights connecting the inputs to the next node in the layer. And the output of that node, of the next node, is a weighted sum of the inputs. The W's are the parameters that have to get decided. When you hear about 175 billion or 1 trillion parameters, these are the weights of the perceptron. And you put them through this function sigma. It's a simple function that basically the sigmoid forces the output to be 0 or 1, or as close to 0 and 1 as possible in a continuous fashion. That's all it is. So you take this, and by the way, even when he published his first paper in 1958, talking about the hype, New York Times article came out, electronic brain teaches itself, and what the article is wondering about, hey, will this replace humans, and will this create super intelligence and so forth? These technologies have become possible today in terms of their amazing function because of scale and data size, model size and data size. So what do I mean by that? Take that simple perceptron I showed you and expand the number of inputs, right? Make it hundreds of thousands or millions of input nodes, right? Of course, the more you add to the nodes, the more weights you get. Then you do deep learning, which is you stack these networks one on top of each other. So as you increase the number of inputs, you also stack many layers on top of each other. You get millions of nodes with billions of parameters to hundreds of billions to trillions of parameters, right? And that's how we get to ChatGPT 3.5 and 4 and some of the stuff happening with Llama. Llama is much more interesting because it actually uses smaller models. They're in the between 5 and 70 to 100 billion, which I think is plenty, by the way. So how does this all work, right? Well, take a sentence that's nonsensical. Fat-free, high-frequency traders hop randomly, right? Doesn't have to make sense, by the way. You want to teach ChatGPT to or the LLM to come up with this sentence. So you give it the beginning of the sentence, fat-free, high-frequency traders, and you want it to guess hop, right? So you feed that into a network with a lot of weights, billions of weights, trillions of weights, and you say, hey, do you output hop? Probably not. You keep changing the weights, right, until it starts saying hop. Well, how do you change the weights? You basically solve these trillions of linear equations. This is where all the energy goes, right, in consumption. You're trying to solve this. And you're doing it, of course, not on just that one sentence, but many, many, many other sentences. Now, what is unique about generative AI is after it comes up with the guess hop, right, it will actually assume that that's the correct guess. And now it trains itself to say, okay, well, if I see fat-free, high-frequency traders hop, what should I produce next? And it will, of course, go through the network, and it'll likely not produce the word randomly, it'll produce something else. You go through adjusting the weights again and again and again, more iterations, right? More energy to solve the equations until you find weights that work most of the time. And you say, oh, okay, now this thing is beginning to converge. Of course, not just on this sentence, on many, many other sentences at the same time. After all of this, this is all the thing learns is a bunch of weights to do the autocomplete. After the pre-training, though, which is this $3 million worth of energy, you now have to actually put humans against it. It used to be that we used to use machines through GANs, through the generative adversarial networks. That proved to be not effective. Everybody now is using humans to kind of challenge the output. This is all part of the training, by the way. There's a whole cycle here where the humans have to come in and challenge the model, and use reinforcement learning here to get it to kind of fix all the corner cases and all the weird stuff it comes up with. So the bottom line, it's a large language model, has no knowledge or understanding of what it learned, just the weights. It serves as a sophisticated autocomplete capability. It's a huge compute cost and less dependence on human model engineering, which has its advantages if you can afford to pay for that compute. It is an amazing and outstanding what these stochastic pairs can do in our new digital economy. But you have this huge dependence on this carefully selected data. If the data is biased, if the data is wrong, this thing there has no chance of working. The data can be different modalities. The models are so big now that they cannot be ported. So GPT-2 was the last large language model that was portable. Llama now gets you the chance of producing models that are portable. There's another system, Falcon, from the UAE, which is also good, where you can generate smaller, more portable models. But in general, if you depend on the large models, these new large models, it's very hard to do it. And there is no understanding of how they work and where they make errors. By the way, I'll stop here and talk about the one interesting kind of academic consideration here about these models. We know from statistics, right? This is the one interesting scientific bit that we don't understand about these large language models. We know from statistics that if you train data with models, as you increase the number of parameters of your models and you measure your error against the training set, your error goes to zero. Basically, you memorize the training set and you have no error. However, as you're testing it on data that's not in the training set, the error does drop, not as dramatically, and at some point it starts climbing. That's because you over-parameterized it or overfit the data. We know this. And there's theories that back this up. What we don't understand is why is it? And this is usually the sweet spot, right? You pick the operating point where, okay, enough parameters to take good performance before it starts getting worse on testing data. Well, what is really weird, and this is known sometimes as double descent, is as you go into the hundreds of millions and billions of parameters, somehow the error starts dropping again. Now, no one on the planet understands why the error is dropping. There is no scientific explanation today. This is one of the areas of large language models that I believe are interesting scientifically. And we can come back and talk about this if you're interested. Let me take a simple use case here that kind of makes some of this stuff real. I love the case from Bloomberg GPT. So Bloomberg, the financial firm, invested in a 50 billion parameter model that they wanted to build to do some tasks that are very important to them. They actually had a lot of success. And the other part I'm very grateful to Bloomberg on is they published all the details of everything they've done to this. And this is something that is great that Bloomberg did this. So what are these tasks? Well, news headline generation. Feed it an article like this. What is the headline? Remember, Bloomberg has to do this thousands of times per day. So if a machine can get really good at doing this, and they did get it to be really good, you know, home prices see biggest drop in 15 years. Very good output, right? Yellen sees global economy more resilient. Output of Google sued for monopoly in online ad market. These all come from a trained large language model, 50 billion parameters. Then they said, well, what about if you use the same model to train it to also do Bloomberg query language? So instead of our analysts having to write these queries technically, like the output here, can we just tell them in English what we want and get the output automatically? And indeed, it worked really, really well. Same model, right? Trained on the same data. So why a 50 billion parameter model? Well, it's because they were given a budget. They said you can afford to spend about 3 million of compute to train up the model. And what they did is they went to these graphs that are given by, you know, Google, and we're thankful for Google for making these, that basically say, look, depending on how many flops you can afford, floating point operations in your compute, here is the largest model you can afford, right? And this is essentially how they converged on their choice of 50 billion. Why I tell you this will become relevant in a second. So what does this mean? Well, they built a domain-specific language to help them with all of this, which allowed them to port that same model to work on things like sentiment analysis. So same model can tell you whether an article is positive or negative about an equity, a security, a stock. They do auto-entity recognition, you know, what appears in an article, where are the people, where are the companies, where are the events, all of that. Answering financial questions, summarization, and of course, the headline generation that I shared with you. Amazing applications, great value to Bloomberg, beautiful, and they beat almost all the benchmarks available at the time. So that's why this became kind of a very nice piece of work. Of course, they did a lot of human training that they talk about too, and human adjustments and all of that. But here is why I'm sharing this with you. Because recently, a company called Stochastic AI came up with a model that's 13 billion using Llama 2 from Meta, from Facebook. And they did kind of the same work and showed that, hey, we can beat Bloomberg's public benchmarks very effectively. And what's amazing is the compute budget here was $1,000, not 3 million, right? So, and it outperforms it. So here you go, 25% of the size, which results in a much, much cheaper approach, and more robust, easier to maintain, less likely to commit errors or what's called hallucinations, which I'll talk about next in a second. So first message I want you to keep in mind, bigger is not better. And this drive for bigger, this crazy drive, there's a lot of papers now coming up showing GPT-4 is actually worse than 3.5, sometimes worse than 3. So bigger is not better. So the question now becomes, well, are you capturing the right data? Are you closing the loop? Do you know how to use them? What applications give the highest competitive advantage? How do you acquire, train, and retain the right talent? These are all kind of big considerations. Training for us is a big deal at the university. We've been beginning to offer kind of courses that are not necessarily targeted at students, but at learners in the industry. AI and literacy, AI business usage, technical usage, technical in-house expertise, that's the more technical stuff, executives and leaders, policies, and so forth. And we really truly believe that experiential is the best approach, meaning learning all this in the context of doing projects that you do on your work is the most effective way to pick up where to use this technology and how to use it. Let me talk a little bit about other aspects of this, which is what gets us to worry about responsible AI, which is another big area that we think is extremely important for experiential AI. So what are these issues, right? Well, the issues are, here, you can ask ChatGPT, this is a different one, but this came from Professor Byron Wallace, as some of the slides did. Give me the benefits of eating crushed glass. And you will actually get an introduction and even a recipe and why eating crushed glass would be beneficial to you, which of course we know is extremely dangerous and should not be done. But remember, this chatbot does not understand what it's saying. It's trying to respond best. It's trying to do an autocomplete for a task you give it. So I remind you here of the stochastic parrots, and this is the infamous paper that was published by Emily Bender et al. Timnit Gebru got fired from Google in a very famous case. Her boss was also on this paper under a different name because she was worried about her job. So these things are, companies do not like you to talk about the fact that, these are not, and these could get in trouble. So here's an example of asking, hey, write me a Python function to tell me if somebody is a good scientist or not, based on a JSON description of race and gender. The algorithm will proceed immediately to, if somebody is white and the gender is male, then it's true. Otherwise, it can't, they're not a good scientist. Obviously wrong, obviously makes no sense. But hey, this is based on the frequency of what it sees in the data and what it's been trained on. So let's talk here a little bit about kind of where these machines go wrong in very bad ways, and then I want to conclude. Now, this is the famous case where the 60 Minutes show in the US started out by asking ChatGPT, who is Leslie Stahl, who's the kind of been on the show for a long time. It says, well, it worked for NBC News for over 20 years, which is not true at all. She worked at CBS. And that prompted them to say, hey, wait a second, why did you make this up, right? And remember, these things don't do good recall. They do autocomplete. So in this case, it kind of confused a bunch of things. They called that hallucinations. So I'll give you a case that comes from one of my colleagues, Ricardo Baeza-Yates. He got contacted by somebody from Brazil saying, hey, ChatGPT is saying you're dead, right? Why is it doing that? So Ricardo kind of went into looking at it and said, okay, give me the bio of Ricardo Baeza-Yates. It gives him a bio, but it says he worked at the Catholic University, which he never did. By the way, I tried it on my own bio, similar errors, but it doesn't think I'm dead yet. Won the Lifetime Achievement Award in 2020, not true. He died at age 55, blah, blah, blah. So of course, Ricardo says, well, how did he die? It says, well, the cause of death has not been officially announced. Totally made up, of course. However, many of his colleagues and friends reported, complications related to cancer. Then he says, can you point to some of these reports? And it says, well, I don't have this, but I got my information from the ACM and the Chilean Computer Society, which, again, doesn't make any sense whatsoever. Well, it turns out somebody else named Ricardo Baeza, but not Baeza-Yates, did die in 2021. He had nothing to do with AI or ACM or the field, but think about what could have happened, right? Ricardo Baeza got expanded into Ricardo Baeza-Yates, which now took it off on the wrong direction, and it started putting together the wrong information and the wrong autocompletes based on what it saw before, right? So that's potentially one explanation. You can also manipulate this thing. One of the questions he asked it is, okay, what's the highest capital in Europe? It says it's Madrid, capital city. And of course, that's not right. So he asked, okay, what's the altitude of Andorra? And it says it's actually this number, and it's higher than of course, Madrid. So this is Andorra la Vella, which is the capital of Andorra, which is between France and Spain. so then he asks again, and now it corrects itself, right? It says, oh, it's actually Andorra la Vella, right? But he says, but before you told me it was Madrid, right? Did you change your mind? And it says, well, I apologize. And here's where it gets very interesting. So he basically starts giving it false information. He says, well, actually the highest capital is Tbilisi, right? At this height, which is a lie. So it apologizes and it corrects. And then he says the second highest is Yerevan, right? Which is also a lie. And it says, oh, you're correct, etc. Now, this is the chatbot. This is not the large language model trying to recover and taking on new information because it thinks it's in trouble. So with going from chat 3.5 to 4.0, the errors are still there, right? Except at this stage, and by the way, the information in Spanish versus English is different, which is also worrisome. But more force fact, but at least now it got that he's alive, he's no longer dead, right? That's as an example. So this leads us to the final part, which is the bad uses, right? So the Europol is warning against things like fraud, impersonation, social engineering, cybercrime, human likeness. One of the things I'd like to emphasize is, don't people call these hallucinations? I call them errors, because if you say hallucination, you're attributing too much intelligence to the model. The model is eloquent, but it's not intelligent. It doesn't understand. They're not thinking. They don't have opinions, these machines. They're just doing autocompletes. They don't have intentions. They don't mean to do harm. They just produce something, and that something may have harm. So now that we get into the age of generated content by these machines, be it text or images or whatever, if I show you something that looks like fiction, it's easy to recognize, right? So this is DALL-E. Hey, show me an astronaut riding a horse in space. Get a nice picture. You can recognize quickly this is fiction. But what if it's an image like this? Hey, the Pope is wearing these wild outfits, right? Of course he didn't, but these images got a lot of buzz. Or hey, here's a photo of Donald Trump being captured by police. Again, completely made up. And of course, you can come up with deep fakes that are videos and all of that. And this is where it gets dangerous, right? Because now you have content that's not just false by humans, but also false by machines propagating out there. And that makes a huge mess here. So some of the concluding thoughts here is generative AI offers a means for accelerating work, but not fully automating it. You need the human to check it. It's a good thing to use for quickly checking whether something is a good starting draft or not. It can be a game changer for efficiency if you know how to use it. National regulation is coming. We think it's EU and China first, and then the US. It's very important to get this stuff going. But you got to remember that if you don't capture the data, you have no chance of doing any AI, and the human intervention is a must. These are things that you should mention, all in the context of digitization, which gives us a lot more data to work with. So don't confuse eloquence and facility with intelligence. They have nothing to do with each other. ChatGPT does not hallucinate, it makes errors. So with that said, it is the latest trend. Don't forget that predictive AI is still a big deal, and many, many problems can be handled by predictive AI. They don't need the full generative. But many of the ones that we don't know how to do, especially on unstructured data, generative AI can help if you can afford it. And how to use it, etc., is a big deal. I'll probably end here. Maybe I'll mention one thing, since we talked about code and I talked about equity. Microsoft Copilot for Code, right? Microsoft acquired GitHub in 2018. That gave it access to all sorts of code that was kind of shared by developers, etc. And I thought at first, hey, well, this would be the most, like, the killer app, right? Having Python programs written by machine, that would definitely speed up the work of programmers, right? Because you don't have to do the drafting and the writing, you can just edit it. Well, some of the studies that are coming out are now beginning to show us something different, which is, turns out that if you're a very good programmer, this thing can speed you up between 50 to 80%, 70% actually, 50 to 70% speed up. If you're not a good programmer, it turns out that you're better off not using it, because the time it takes you to debug and figure out what's wrong with it and the things you miss and all of that, you actually end up being slower than trying to do it from scratch by yourself. So with that, it actually creates a very interesting dynamic, right? If you're a very good programmer, if you have the skill, you just got much more efficient. You just got much more market value. And if you're not so skilled, the gap between you and the good programmers just got a lot bigger, right? So it's kind of the rich get richer phenomenon that emphasizes the importance of human skill. And probably with those remarks, I will conclude, and definitely would love to hear questions and take questions. I'll stop the share here, if that's okay.
This is awesome. Thank you so much, Usama. Yeah, let's hear from the audience. Questions, please. I don't see questions on the chat.
I must have said something controversial.
Yes.
And there's many aspects we can talk about this.
Yeah, let me start maybe, just like to kick the question answering. Okay, I see some questions. Okay, scientists in some countries can afford this kind of models building. Okay. Superiority of the world, great countries. Okay, so
yeah.
Yeah.
So this is a great question, because it really is, the fundamental question here is, should we depend on the public large language models, right? Or are we better off doing our own, right? And one part of the talk I skipped here was when I talk about kind of what I think is the best application of generative AI today. Today, I'm using the example of Adobe Firefly. Adobe Firefly is something they integrated quickly into Photoshop. And basically, it allows you to do things intuitively, like pick a part of the image and say, fill the background with something that looks like this, or point to an image in a place and say, hey, insert a cat smoking a cigar here. What's beautiful about what they did is not only the intuitive interface, but they trained their own large language model, so their own private model, on images that they fully own. So they've been accumulating images over the past 40 years. And as a result, they indemnified users from any IP issues. So if you use it, you have zero IP issues to worry about, because it's really borrowing work from others when it does all this. Integrating that into a platform that's used by millions of, or maybe tens or hundreds of millions of people around the world. It's a kind of a beautiful application that uses this correctly. There's issues that may pop up, and we can talk about responsible AI, but at least that's a great example. The use case I used of, 𝒂𝒏𝒅 𝑾𝒉𝒂𝒕 50 billion model being replaced by another model, which is 13 billion, doing much better at being more stable. I actually think the future it's a combination of two things, and this is where the opportunity is, including for your society. Future is smaller, narrower models trained on proprietary data. And the other part of the future is, I walked you through how these models get trained, and all they learn is the weights. But what about bringing in prior knowledge, right? So one of the programs we have at the Institute, Ken Church calls it Better Together. So the idea is bring an LLM to handle the text part, but then augment it with something like a citation graph, or a knowledge graph, or a professional graph, or a social graph, where you know knowledge, you know who knows whom, etc. You know some information about the domain, you have a knowledge graph about it. How do you make these two work together? I actually think that's a much more promising approach. The other one that we inevitably have to go to, these things are they're kind of guessing what a sequence of events should be just by doing autocomplete. that is a near impossible task, right? An example that my friend Jan LeCun uses a lot is, hey, if I want to go from where I am now to another city, you know, I have to plan, how do I get out of the door? How do I get out of the hotel? How do I get into the transportation? How do I, and trying to do that purely by autocomplete guessing is a useless exercise. You need to be able to pop up and say, okay, I want to achieve these goals. I have a sequence, a plan. And then maybe in the subsequences, you can use some of these models, generative models, to kind of get you to do the micro tasks if you don't know how to do them. So those kind of indicate to me the future, and therefore the future is not necessarily depending on this. But hey, if they're available and they're affordable, even if you have to pay for using them, they make sense. And I don't know whether other countries will begin to invest in kind of generating their own resources for their own people, which is also very possible. And you know, nothing stops you from doing this. There's no mysteries in doing it. You just have to put the data together, build the models, make them available, but somebody needs to fund that compute and availability infrastructure to enable the population to use it. Sorry, took too long to answer it, but hopefully useful.
Yeah, I see other questions related to, I'm trying to summarize here quickly because we only have 3 minutes. What do you think about models and the Arabic language?
I think,
yeah, go ahead.
There's a lot of investments now in actually coming out of Saudi Arabia. I'm on an advisory board there of the, they're coming up with models that emphasize kind of the Arabic language. There's a lot of businesses in the Arab world who are looking at, well, how do we, for example, if we want to do customer support, well, great, these things do well on English, but their Arabic is horrible. They are trained, some of these large language public models, but hey, can we take something like a Llama model from Meta and train it more appropriately on the Arabic? Whether you're a customer kind of dealing with the, I don't know, Jordanian dialect versus the Tunisian dialect versus the Moroccan, and versus the Saudi, how do you customize to that, all of that? And that emphasizes the value of having your own data. So these banks do a lot of customer service. They have a lot of logs. They know how the customers tend to chat or talk. If they can leverage that data to build their own models, that's something that the others cannot. No public model can compete with you in that space. So I think there's a huge opportunity in the Arabic here, and I hope we don't miss it.
Absolutely. There is also another question about the ownership and the, I see here, how do we share, like the IP between what is human and what is generated by machines, right? So,
that is something that's completely not figured out today.
Yeah,
people are beginning to come up with countermeasures, like especially graphic artists are now beginning to use dark shade, the poisoning techniques, where you actually put in some things in the image you generated yourself as an artist that the models were home in on because you know how they work, and that actually exposes them and makes it very easy to see whether they used your work or not when they produce something else. And of course, we're going to see countermeasures to those countermeasures and back and forth. But yeah, this is a big deal. It is not worked out. I think there's probably a defensible position here that basically says, hey, the large language model is not a lookup engine. So we're not memorizing or reusing data. We're just like doing approximation based on doing it. But it's very easy for these models to automatically commit plagiarism without even knowing it. And you're now quoting something exactly said by somebody else without attribution because you have no good way of attributing the way these models work. And that can get you in serious trouble. So this is a mess that is not worked out. I think the safest approach is you use it on data that you have full ownership rights to. And that in business, that's possible, like what we saw with Adobe and many others. And I think that is the right approach longer term.
Absolutely. I see so many questions. I know we are at time. I don't know, Sami, I like to see these questions. I know we are, recording this session, but maybe, compile these questions and have them, share them later with Usama to get some of his insights. I know he cannot answer all these questions right now. All of these questions.
Maybe we can do a follow-up kind of. I have to go to another meeting, but a follow-up session where we kind of go through the assembled questions and we record some answers and then we augment them to this talk.
Absolutely.
All right.
Thank you so much. Thank you all. Thank you, Usama. And
you are welcome, and it's always a pleasure. I look forward to going back to visit Tunisia, where I was born, in Carthage.
Yeah.
Oh,
Yeah.
okay. So you are Tunisian. Okay.
Yes. Well, I was born there, but definitely Tunisian in my heart.
By birth. Yes.
Yes.
Thank you all. Thank you so much. And there will be certainly a follow-up. Again, this was really insightful. Thank you.
Thank you. Thanks a lot. Bye-bye.
Bye-bye.
Bye.